Okay, in this video we're going to pick up where we left off, and the last time I was showing you the significance of the way this, actually the significance generally of this geometry that we see, which has been kind of left for us as a puzzle or a key. But then on top of that, I was also showing you how this geometry built on itself every time. This right here was taken from a Rosicrucian temple, as I mentioned. And one of the things that we wanted to take a look at is we wanted to take a look at a couple of things. There's numbers inside here that are significant, and the number of rings of the circles that you see here are significant. And also the way this geometry builds upon itself, as you see here, is significant. Because if you take a look at each one, the triangle is perfectly bound by the circle, which is perfectly bound by the triangle, which is perfectly bound by the circle, and so on and so on. The squares have the same diameter as the circles do, so we've already seen that, so that covers both the circles and the triangles. But then, when we were done with that, we were taking a look at the circles themselves, and we were looking at specific numbers. Now you remember there were 10 concentric circles, and that relates back to some of the diagrams we've seen a long time ago. Just to reiterate, right here is an old drawing from Athanasius Kircher, and we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the 10 concentric circle things here going on. So when we come back to our diagram here, we have the same thing. We have 10 concentric circles. And if we look at the numbers of these circles, if you remember, the outside circle we got from Stonehenge, because this right here, this red line that you see moving across, is 360 feet in diameter from here to here. And that's how we got our largest diameter. And so we took that and we made this our largest diameter, which of course, since we have 10 concentric circles, that made this one 36. 3 plus 6 is 9 is 72. 7 plus 2 is 9. 108. 1 plus 8 is 9. And remember, these numbers were significant. 144, which comes to 9. 180, which comes to 9. 216 comes to 9. 252, 288, 324, and 360. The digital roots, or when you add all these together and reduce them, they all come to 9. And the same can be said for these triangles right here. Now let's take a look at something with Metatron's cube real quick. Metatron's cube projects all of the Platonic solids that you see right here. So with Metatron's cube, you can project the tetrahedron, the star tetrahedron, which is a 3D version. You can see where both of the tetrahedrons fit together, and they actually would sit inside of a sphere. And if you take a look at the sun, a lot of times you will see that the sunspots occur along these two lines that you see right here when you take a look at the sun. You'll see that the cube is projected, the octahedron, the dodecahedron, which was considered a long time ago the shape of the universe, the icosahedron, and then of course the sphere comes into here as well. And we're going to be taking a look at the Earth today because there's some interesting information about this geometry that tells us about the Earth. Now, a while back I showed you the geometry behind the eyeball, and this is what this is. This is actually gathered from stanford.edu. And if you see these you see these circles in here, this is from Metatron's cube, 1, 2, 3, 4, 5, and the dimensions of the eyeball that you see right here fit into this thing just perfectly. And you must remember that the eyeball is fitting in here. It is a 3D formation, just like what the Earth is. It's a projection of a sphere inside Metatron's cube. So this is kind of an example of what we would see at a much smaller level, and then we'll take a look at what we see at a larger level. This right here I showed you a while back, and it shows you what modern science has measured the dimensions of the inner parts of the inner core of the Earth to be, and it's compared to at Metatron's cube dimensions. So if you take a look down here, you can see that the Earth one is slightly different. Go ahead and expand that for you a little bit. It's slightly different, but relatively the same. So this large circle right here, that's the mantle, this area right here. The second size smaller would be the outer core, and the inner core would be this size circle right here. If our circle is 360 degrees across, 360 feet across, or just use that number 360, then each one of these would be a 72. But you can see if you compare, and these are actual comparisons, and then right here I have the comparisons in percentage, and the differences that you have right here would be the differences from the small here to the medium. You have a 2% variance. From the medium one to the large one, which is the highest one, that's between the orange and the green one. There's a 5% variance, but between the very smallest one and the very largest one, there's only a 1% variance between Metatron's cube and what their measurements of the inner parts of the Earth are. So I thought that would be interesting for you to see as we move on. So here's where it starts to get kind of interesting. If you remember, I told you there were 10 concentric circles. And this first one was 36, and this last one was 360. Well, I happened to look up some information, and if you take a look, this 360-foot diameter more than likely has something to do with frequency. And the reason I say this is because if we take a look at this chart right here, you'll notice some similarities between the numbers that I showed you in the circle and what you see right here. At 0.1 hertz, you have 36 degrees. 0.2, you have 72. 0.3, you have 108. 0.4, you have 144. 0.5 hertz, you have 180 degrees. 0.6, 216. These are the exact same numbers that I showed you that are located inside this circle here. This last one, being 360, is equivalent to 1 hertz, which means 1 turn around the circle. And that means degrees per second. So that means it takes sound 1 second exactly, or roughly, to travel around this whole circle, which is 360 feet in diameter. Now, I'm pretty sure that the 360-foot diameter has something to do with the Earth, and let me show you why. So the speed of sound is 1,130 feet per second. Okay. So now let's take a look, and we have 360 feet across. So if we take 360 and we want to get the circumference of this circle, then what we do is we take a look at our formula here, and the circumference of a circle is 2 pi r, which means it's 2 times pi times the radius, or it could be 2 times the radius times pi, however you want to do it. So in our case, we're going to do 2 times the radius times pi. Well, 2 times the radius of that circle is 2 times 180, because the whole diameter is 360. So 360 times pi will give us the circumference of that circle. So let's go ahead and multiply that out. 360 times. And you have to remember that the way that these guys did pi a long time ago was slightly different. They used the 3.142 142,857. 3.14. Okay, I had problems with my calculator there for some reason. Okay, so 3.142857. Now 1.2 142,857 turns out to be exactly 1/7. Okay, and if you remember, the old pi is actually 22 divided by 7. All right. So if we take 3.142857, which also, by the way, 142,857 comes out to reducing to 9. So we have 1 plus 4 is 5, plus 2 is 7, plus 8 is 15, plus 5 is 9. 15 plus 5 is 20, plus 7 is 27, 2 plus 7 is 9. So the 142,857 is a cyclic number. It's also a very important number. And so remember, the diameter of our circle is 2 times the radius. So that's 2 times 180, which is 360. That's the diameter of our circle. So we multiply that times the diameter. We get 1131.42. Now let's take a look. Right here, 1130 feet per second. So that means that it takes sound 1 second to travel around this whole circle. Now here's where it gets really interesting. So knowing that this had something to do with the Earth, and I decided to use the 1/7 because the 142,857 comes out to be a very interesting number. When you take this number and say you take the 113142, so let's just do this again. We'll take 360, which is the diameter of the circle, times 3.142857, which is pi. Now we're going to divide that by 1/7, and that is 0.142857, and the number we get is 7920. Now let me show you something very interesting about that. The diameter of the Earth in miles is 7917.5 miles. Now if we take that number and we multiply it times pi to get the circumference of the Earth, then we would multiply that times pi again, because now we have that number 7920, which is the diameter of the Earth, 3.142857, and we get 24,891, and the circumference of the Earth, 24,901. You can see we're, according to what they give us and according to what we have, is approximately a 5 or 10 mile difference. But the reason I like the geometry that we get from the using the other kind of pi is because we can use the nines to check our work. For example, 7 and 9 is 16 plus 2 is 18, 1 plus 8 is 9. So I know that this number right here is more than likely correct by looking at it. So we get this interesting thing about the Earth here. By using the 360-foot diameter divided by sevenths, we actually get the diameter of the Earth, the number, the 7920 number. And by means, this is not everything all explored out. This will probably be needed to be done for other planets and other things like this, but it gives us a good solid foundation to work with on how this kind of ancient geometry and math was done a long time ago. So now you can see that we have frequency tied into all of this. It's tied into the concentric circles. 360 is tied into this number measurement, and you'll also notice numbers like 432, 468, but what you'll also notice about all these numbers, and you can see this as you count from 0.1 to 1, there's 10 until you get to 360, which could have had something to do with the reason why they were using base 10. You'll also see numbers like 432, 468, 504, but what you're going to notice about all these numbers is they all reduce to 9 in the frequency when we're talking about hertz. Now, last thing I wanted to show you is something that was from a presentation given by Graham Hancock before he put out Magicians of the Gods. And on his map that he presented in this presentation, he showed these major locations around the Earth. And of course, Giza was considered the place. It's the center of all of Earth's land masses, by the way, in case you didn't know. And that's more than probably why they did this. It's been also understood that by many researchers and scientists that this is the prime meridian that was used a long time ago, is where the Great Pyramids are, so that we have a 0 degrees moving down there. Now 0 degrees would also stand for 360 degrees. 180 degrees is right over here where Alaska is, and the reason why that is because if we zoom out, we'll see that if this is where Giza is, then on the other side we have Alaska right here. So that would be 180 degrees. So you can kind of see on both sides of the Earth. So here's Giza, here's Alaska, and that's kind of what he's showing right here. So at 180 degrees on the other side of the Earth, we have Alaska. Notice these red dots. These are Paracas. We have Giza, Angkor. These are locations, and look at the degrees that he's using down here. He's got 180, 216, 252, 72, and if we take a look, we'll see that 36, we have 72. See, he's got the number 108 there. We have 144. And he said this is a work in progress, snapshots of a work in progress. All of these numbers, 180, 216, 252, 108, 36, 54 was one of the triangles. They all have something in common. The only thing that's a little bit different is the number 48 here, but let me show you something, one way that we can confirm what he's doing with our own information. So halfway in between 0 and 72 is 36. So if I just kind of like draw like I'm just going to draw a square that goes from 0 to the 72 degree mark. And whatever that is, I'm going to divide it in 2. And that would be basically 1/2 of what we were looking at. So if we zoom into that real quick, and we take a look where that edge lies, which is 1/2 and halfway between 72, you'll notice something kind of interesting. Here's India, and here's what he's showing right here. But then at 36 degrees, we would expect to see something. And what we would expect to see is something right here. What he's pointed to is something right here, but what is right here? Because that's what we're seeing in this map. This is 0, this is 72, and right in the middle, right here, is what we're looking at when we look at this area right here. And what that is the ancient city of Dwarka. This is the Indian Atlantis, and apparently this is sunk off over here. So Dwarka is actually located right here. See, there's Dwarka, but the sunken city is actually located somewhere around here, and on that map it would put us right at the 36 degree mark right there in between 0 and 72. So what this tells us is it tells us that at every 36 degrees on this map we should find something, possibly some kind of an ancient land or or some kind of an ancient megalith or something like that that's important according to what he's found so far. So this is a work in progress. 180, 216, 252. We have 324, 288, 252. There's 252. There's 216. There's 180. See, these are all on there. I don't see 144 on there, which would be probably somewhere on the other side of Alaska. But this right here, this target, concentric circles right here, gives us a clue to where we might want to look if we're looking for other ancient locations. So there we go. So there's frequency tied to the Earth, tied to its shape, tied to the inner parts of the Earth and Metatron's cube. And so, and these particular numbers and their frequencies that always reduce as you can see right here, 0.1, 0.2, 0.3, 0.4. And of course, this would just repeat if we were going to higher numbers and stuff like that. But you can see it repeats. When we get to 2, it's 720. Down here, 0.2 is 72, which is just 10 times as much. So these particular numbers, and associated with what we see in these concentric circles, in association with what we see in all of this geometry and Stonehenge and everything, is related to frequency, man, the Earth, and ancient locations that we have around the Earth. So anyways, I hope you guys found that interesting, and as I come up with more information, I'll let you know. By all means, this is just kind of it is a work in progress. It's not finished, but you can see how by taking these numbers, how you can get the actual dimensions of the Earth as calculated by science. And by using Metatron's cube, how we can get the size of the inner parts of the Earth and stuff like this, and the circumference of the Earth. And by using frequency, how these numbers kind of confirm themselves. These are the right numbers that we use when we take a look at this stuff. So this is just part of the puzzle, and there's obviously more to come, but I wanted to show you how these guys may have done some of this a long time ago. You guys take care, and I'll talk to you soon.